In this video, we will consider a few miscellaneous thoughts on uncertainty that did not make it into the first edition of your text. Some people would argue that all uncertainty is knowledge uncertainty, and that given sufficient knowledge, the variability of the universe would disappear. I can't quarrel with that position. So let us consider the line between knowledge uncertainty and natural variability somewhat arbitrary. However, until that great breakthrough in knowledge occurs, it's certainly convenient to speak of natural variability as a source of uncertainty. It's easier to learn the mean and standard deviation of the peak daily temperature in January in Baltimore than it is to acquire the knowledge needed to build the model that will predict tomorrow's temperature with perfect accuracy. Risk analysis has been described as evidence-based decision-making. Some early advocates of risk analysis might argue that in an ideal situation, the evidence should make the decision about which choice yields the best result. Purists might prefer that given the information available and accessible, and that presented with the same evidence, everyone involved in decision-making would come to the same conclusion. Evidence, then, is the actual information that helps the risk manager or other decision maker reach a conclusion and form an opinion about something. Climbing the evidence hierarchy, shown here, increases the predictive power of the decision. Analogical evidence is a weak form of evidence that suggests that something that is true about one thing is also true about another due to its similarity. Anecdotal evidence arises from small sample sizes, but it's frequently not representative of typical evidence. Anecdotal evidence indicates something is possible, but it does not establish its likelihood. It's usually used due to the lack of other evidence. Statistical evidence forms the basis for providing evidence of causality, but it does not prove causality. Many factors in a complex system may contribute to a specific effect. Statistical inference helps establish causal relationships. And facts represent actual occurrences that can be verified. They include empirical and historical evidence, as well as scientific facts that can be confirmed with repeated experiments. Here we have the DIKW pyramid. Data are raw facts that have no meaning of themselves. Data simply exist in a usable or unusable form. A spreadsheet database full of peak daily streamflow measurements is an example of data. Information consists of processed data. Data are processed specifically to increase its usefulness. Using the streamflow data to produce a flow frequency curve is information. Knowledge is the collection of relevant information with the intent to be useful. Thus, knowledge is a deterministic process. Someone must put forth effort to acquire knowledge, and this knowledge has useful meaning to the seeker. Using the information from flow frequency and depth flow curves, analysts can develop knowledge about the depth and frequency of flooding in a town. Wisdom is the ability to increase effectiveness. It both requires judgment and it adds value. Wisdom is the process by which we discern or judge between right and wrong, good and bad, ethical and unethical. Knowledge of a flood risk can lead to wisdom in managing that risk and preventing similar risks in the future through flood risk management measures and land use controls. Understanding is a cognitive and analytical process that runs throughout the wisdom building process. It facilitates movement from one tier to the next. Understanding is the process by which we recognize information in data. It is how we construct knowledge from information, and perhaps most importantly, it's how we take existing knowledge and synthesize new knowledge from it. In risk analysis, we want to make decisions as high up on the knowledge scale as possible. Decisions are not made based on data. The pursuit of data for the sake of its completeness is the equivalent of a false god for those who pursue evidence-based decision-making. What risk managers need is wisdom. What risk assessors can best provide is the information, knowledge, and understanding necessary to give birth to that wisdom. This figure demonstrates the basic trade-off between the cost of reducing uncertainty through evidence gathering and the amount of uncertainty. If you find yourself at point 1 and would like to reduce uncertainty to point 4, it's going to cost you. A good evidence gathering strategy is to gather only the evidence needed to make the risk management decision. The shape of the curve makes it clear that the only way to reduce evidence gathering cost is to increase uncertainty. The only way to reduce uncertainty is to devote more resources to evidence gathering. A good risk management process that establishes realistic expectations of the risk assessment and other analyses conducted is the best way to address this trade-off. Gathering data is wasted time, money, and effort if it does not add instrumental evidence in the form of information, knowledge, and wisdom to our decisions. A piece of information is relevant if it could impinge on the decision in some even subtle way. Relevant information may make one risk management option look more appealing than another, or it might make a stakeholder happier. Most of the information in a system of accounts is relevant, but it is not instrumental. Relevant information can be categorized as instrumental or non-instrumental. Instrumental information is a piece of information that can alter the decision that is made. This would include decision criteria and other things one needs to know in order to make a decision. Non-instrumental information refers to information that would have no instrumental value, even if it were directly available. That is, these data may be in some way relevant, but they wouldn't affect the decision to be made. Some individuals and some organizational cultures are prone to gather too much data that do not produce higher levels of knowledge on the pyramid, or data that produce information that's not needed for decision making. Analysts may pursue information because it appears or is believed to be relevant to the decision at hand. Then, having spent time, money, and effort pursuing that data, analysts or decision makers treat the information as if it's instrumental when it's not. Sometimes the mere act of pursuing data can lead people to use it to make choices they would not otherwise have made. Having more information may reduce your anxiety, but unless it changes your decision, it's not worth the cost of obtaining it. Ask yourself, could this additional information affect the decision? If the answer is no, forget it. If the answer is yes, then ask how likely is it to change the decision. If the possibility is remote, you may not need the information. Do not pursue information to perfect your decision. Pursue it when it might affect your decision. How much information do you need to make a decision? Let us reframe that question as, when is a decision needed? And then we can consider it further. Consider this figure to help visualize the competing forces at work. Imagine a perfectly scalable relationship. As analysts spend time and money to increase their evidence base and knowledge, they are adding value to decision making as they increase their confidence. If the analysts do not take enough time, a decision can be made without knowledge that may have added value to the decision or even changed it. If analysts take too much time and spend too much money, the value of the additional information decreases. The point to take from this figure is that there is a best time to make a decision, and that time comes before all the evidence that is available has been collected and weighed. The image helps us visualize the competing forces at work when trying to find the best time to reach a decision. Too little time and the decision is made without knowledge that could have enabled a more informed and confident choice, generally reducing risk. Too much time and the benefits from the alternate solutions are delayed, costs increase, and in the case of some problems, losses or pain continue to increase. The figure shows the optimal point for making a decision occurs at the balance point between taking sufficient time to obtain the required knowledge to decide effectively and avoiding the loss in information value due to delaying the decision. As you might suspect, finding this optimum does not happen often in practice. Here are some traps one can fall into by deciding too early. Impulsive decision-making or shooting from the hip. Planning fallacy, that is underestimating how long it takes to get things done. The primacy effect, weighing initial events, for example, decisions made in early iterations, more than later ones. Risk neglect. This is the inclination to ignore risk when making uncertain decisions. The snowball effect is the common bias of adopting the views of the majority. Ill-advised shortcuts that rely too heavily on convenient facts and gut feelings are another trap. Here are some traps one can fall into by deciding too late. Paralysis by analysis, the tendency to seek information that cannot affect the outcome. Focusing on the analytical process rather than on its result. Review anticipation tries to preempt negative comments that could be made by trying to provide every bit of information conceivable. Procrastination is waiting too long to begin actually deciding. Risk register complacency fails to actively manage high and medium risks to prevent their occurrence. Maintaining the status quo by doing this analysis the way past analyses were done. Job security occurs when an analysis can be continued for as long as possible. Lack of experience can result in mistakes and delays that extend the schedule and expand its budget. Fear of litigation may drive the desire to gather additional information. The recency effect. This is the mistake of weighing recent events more than earlier events, encouraging a delayed decision. Normalcy bias is failing to respond effectively to an event, delay, or failure that has not happened before or that was not incorporated. Fear that someone will criticize a mistake or missing data can lead to prolonged information gathering. And finally, vertical team failure occurs when decisions previously made by the team are not subsequently honored, resulting in delay. Residual uncertainty. The uncertainty that remains after the best possible analysis has been done is called residual uncertainty. Each risk management activity begins with significant amounts of uncertainty. A good risk management process will establish the decision context early. It's part of a comprehensive strategy to reduce uncertainty in a cost-effective and efficient manner. When the analysis ends and efforts to reduce the uncertainty further have ceased, the uncertainty that remains instrumental to decision-making is residual uncertainty.